Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So we have to find the absolute extreme values of the function on the given interval. And the function is y equals x plus 2 cos x, and the interval is from negative pi to positive pi. So we have to find the absolute maximum and absolute minimum values for this function in this given interval. So the first step is to find the derivative of this function and then set the derivative equal to 0 to find the x values at which the derivative is equal to 0 or where the tangent is horizontal. Because the tangent is horizontal at peak and valley points on the graph of a function. So let's start with the derivative. The first term is x and the derivative of x is 1. Now in the second term, 2 is the coefficient of the term, so it will stay as it is. And the derivative of cos x is negative sin x. Now we can set this derivative equal to 0. And 2 times negative sin x is minus 2 sin x. Now we can move this sin x term to the left side of the equation, and that will make it positive. And now we can divide both sides by 2. So the 2's on the left side get cancelled out. So we have to find the x values in this given interval for which sine of x is equal to 1 over 2. Now we can analyze this given interval to find the x values at which sine x is equal to 1 over 2. So we can break down this interval into two parts to make it easy to find the x values. So one part can be negative pi to 0, and the other part can be 0 to pi. Now 0 to pi interval covers quadrant 1 and quadrant 2, and we know that sine is positive in quadrant 1 and quadrant 2 as per the cast rule. So in quadrant 1, x will be equal to pi over 6, because sine of pi over 6 is equal to 1 over 2. And in quadrant 2, x will be equal to pi minus pi over 6, which is equal to 5 pi over 6. So these are the two x values from 0 to pi. Now from negative pi to 0, this interval covers quadrants 3 and 4, because we have to go in the clockwise direction from the positive x-axis. So I can just show it to you here. So 0 to negative pi go like this. And sine is not positive in quadrants 3 and 4. So we got sine x equals 1 over 2. So therefore, there is no solution for sine x equals 1 over 2 in the part of the interval from negative pi to 0. So that means there are only two x values in the interval negative pi to pi where the derivative is equal to 0. Now we have to find the absolute maximum and absolute minimum for this function. So we'll have to sub in x as negative pi, which is the lower bound for the given interval, pi over 6, 5 pi over 6 and pi, and then find which of these x values give us the absolute maximum and absolute minimum. So let's start with x equals negative pi. So we sub in x as negative pi in the given function. Now cos of negative pi is equal to negative 1. So we get the 2 times negative 1 is negative 2. So we get negative 5.14. Now we can sub in x as pi over 6 in the function. So we get cos of pi over 6 is equal to square root of 3 over 2. And we can cancel out the 2's. Now we can add these terms, and I got 2.26. So this is the y value at x equals pi over 6. Now we can use the next x value. Now 5 pi over 6 lies in quadrant 2, and in quadrant 2 cos is negative. So the related acute angle for 5 pi over 6 is pi over 6. So we can rewrite cos pi over 6 as negative cos. You can also use a calculator to evaluate cos 5 pi over 6, but this is the manual way to do it. Now cos of pi over 6 is equal to square root of 3 over 2, and then since it's minus, so the whole term will become negative after multiplication by 2. And the 2's will get cancelled out. Now we can evaluate this expression. So I got 0.886. Now we can use the upper bound for the given interval x equals pi in the given function. Now cos of pi is equal to negative 1. And 2 times negative 1 is negative 2. So we get y equals 1.14. Now we can compare these values to find the absolute maximum and absolute minimum. So the absolute minimum value is the smallest value we got, which is negative 5.14. and absolute maximum is 2.26, the highest value. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.